Hello and welcome to Flying High with Flutter. I'm your host, allenwyma, and today we have two very special guests, Shadykhalifa and Thorsten. Sorry, I forgot your last name, and you put Thorsten iPad on here. We sorry about this being so late, but we're having a little bit of technical issues on our side, but it seems like we sorted everything out. So in any case, it's good to have both of you guys back. So Shady made a couple of very interesting articles that I used to actually learn about how to put Rust and Flutter together. And coincidentally, that also has helped Thorsten, right? I think, Shady, maybe we could start with you. Like, how did you actually put these things together, right? You made the isolate library. So, like, what was your inspiration to actually start working on that?
Yes. So the isolate library actually started from when I actually needed a way so I can run asynchronous Rust and also asynchronous Dart at the same time, because actually you can't run the Dart function in other thread, because Dart by design is single threaded. So the way is that it works is that you create a background isolate thread. You run your Rust code in it, or maybe your Rust code actually is multi-threaded by default. Maybe you're using Tokyo for asynchronous code or something. And then later on, you send the response to that thread that actually will send it back to the main thread. And this is how actually it works under the hood.
No, I find this kind of interesting because Thorsten actually gave me access to his repository where he's working on his RID library. And I did see that he's working quite a bit with multi-threaded programming recently, right? I think there's something with the mutex that you're working on. Is that right, Thorsten? Like, what kind of features are you working on right now?
Basically to come back to the isolate first is I'm using that basically to post messages to Dart. So basically, whenever some request was handled from Dart and on the Rust side then can post back that it's done. And the reason for that is multi-threaded. In a multi-threaded environment, you can never be sure that something completed synchronously. Like I say add a to-do, like in a to-do app. And now I actually have to go to the web and fetch something, complete that synchronously, so you wouldn't know when actually that to-do was added, and therefore you can then post back and say added to-do, and that happens via the isolate. Now there's another issue with threading. Multi-threading is basically that in Rust, by default, if you're only in Rust, you can only ever hold immutable access to like a variable on one thread. Like it's just like the compiler would basically make it impossible for you to have two mutable accesses on different threads. However, when you're using FFI, in this case with that has immutable access, or maybe it gets mutable access and tries to update, you're getting a call from Dart, like that basically sends like a pointer. Because that's basically how the communication works. It sends a pointer to something that it wants to, let's say, modify. And then that function will then resolve that pointer to a mutable Rust, because the Dart one is running on the main thread. We have mutable access, which normally shouldn't happen, but in this case it does. And that's why I'm basically for RID, in order to make that safe, I'm using read-write locks. That means basically that every time a thread wants to write to the store, like which basically the whole RID, I get a write log on that store, and now I can update the state of that store. Now, if at the same time a FFI call comes in, that one will require a write log. Or if it only wants to read, right? If it only has to read, it tries to require a read log. And now, in this case, it's guaranteed that it actually will have to wait until the other thread releases the write log. So this way, I kind of got us back to safety in this case. And I can go into more details if you're interested.
I think you should. I mean, that's what people are kind of joining for. So they really want to know all the details about how they can integrate together.
So
Yeah.
basically, So basically, we have to go a little bit deeper there. I remember in the first time we talked,
Yeah.
would have to kind of make sure to kind of free things and after use, and in this case for multi-threading also would have to make sure that the store gets locked and so on. What I did is I built another API on top of that, which basically does all that under the hood.
Okay. Do you have any comments on some of the things he was talking about?
Yeah, basically, I have like some ideas that could improve his design. So my idea is that instead of actually running the multi-threaded look and using blocking, we could actually have like only one mutator thread, and at the same time we can have any other thread, and these threads can actually have a channel that can communicate with this thread by sending commands to the mutating thread that actually will mutate the state, and that way you don't have actually need any locking. I am already doing this for other applications in Rust in general, and the application that I'm building right now, the SDK for application called Subsocial. It's a social network, decentralized social network, by the way. So yeah, the idea behind the way I'm building it is using message passing instead of looking, and also I'm using allo isolate to send the message back to Dart. Maybe I will talk about this about how actually this architecture is going on, and the code of course is open source, so I could share it with you at the end of the call. But yeah, the idea is that we, instead of actually writing the FFI functions manually, like writing each function and which parameters it takes and the return type, maybe it's pointer, maybe it's like status code, and also later we'll send the response back over allo isolate. Instead we only have one function called dispatch that takes a shared buffer or a shared view of a buffer from Dart that contains protocol buffer bytes, and we can share these bytes and serialize it into commands, and then later from the Rust decide actually what we do with these commands, like maybe like send a user a message, mutate the state, anything, and then send the response back also as a over the allo isolate we created. That's the way, and it's like almost, maybe it's a bit slower because parsing parsing of the protocol buffer, but it's really fast. Like it's maybe in bar with just writing raw FFI. But yeah, but still like how actually make it more efficient, because everything now is just in memory. There is no networking between the Rust and Dart. Just everything in the same memory, the shared read and write, and it's like almost safe. I say almost because there is like some catches here and there that needs to make sure. But yeah.
And yes, protocol buffers is an option. And as far as I know, for instance, Rust WASM does something similar there, where they basically like the is it called WASM API or something like that? Basically integrates with the browser. They basically deserialize and serialize, and obviously that's an option, but that would right and like make everything serializable and do that. But that makes everything kind of slow, especially like I say you have a huge list of something, right? Like if you just want to get parts of it, you now have to serialize the whole thing, serialize to have access to anything. So I wanted to basically, with the RID, I tried to give you both options, right? One with the API that is kind of raw, that gives you all the power that you need, but also more responsibility where you have to lock and unlock and free and things. And then on top of that, I have a higher level API that kind of does what you're saying, except it doesn't serialize, but it basically instantiates full-fledged start objects. And so if you have a huge list, for instance, right, it would instantiate that whole list before returning anything to you. But in most cases, that's fine. And in the other ones, you would use the lower level API.
So I think the core of what Shady was saying was that he thinks like having like one thread own the data and then use message passing as a method is definitely a way to do it. And then you were saying using protobuf to actually serialize the data. Is that what I understand, Shady?
Well, the idea behind what I said actually is that for Thurston about instead of locking, you could actually have a one mutator thread and the other thread that actually acting on the data that can send commands over channel, just normal Rust channels. And like for example, I want to add a new to do, so I will have my state machine as enum and send the command to do with the payload to the mutator thread over a channel, maybe a broadcasted channel, so it can be or maybe MBBC, MBSC channel, like multiply producer single consumer channel. So the mutating thread actually doesn't really have to lock anything. It will just receive commands, mutate the data, and whenever you want to read, you can actually send it back over the channel. That actually only works inside the Rust itself, or maybe send it back to Dart. So yeah, that's a way to avoid looking at all. And I'm actually using it inside some of our application. I needed like the client that actually communicating with that with the other thread to be clonable and also can be shared to any number of threads. So what I did is that I spawn a background thread that actually owns the data, owns the state, and take over like what's called the TX part of the channel to this client, and then I can send commands like to over this channel, or maybe write a wrapper around it, like let's say a method that actually under the hood actually using the TX to send the command itself, which makes a nicer API.
Okay, that's definitely really interesting, Shay. I've looked into channels a little bit. My main concern, what I wanted to do was to make the user code as simple as possible, right? With channels directly. So one thing, for instance, when you get a message right from Dart, I give you like a mutable store object to update the store. The state basically depending on the message. And so you're getting that mutable store, and that update message runs synchronously. So I basically lock the store and then I unlock it when it's it, right? Like you just muted it and you don't have to worry about it. For you're instantiating it, obviously then you couldn't like send that mutable store over. Like you have to get in the thread, you just get a write lock. But that's, for me, that seemed a little bit easier than using channels. Like you just say, like you can't even get access to the store except via the.
Yes. Maybe to improve even the performance of locking and unlocking, you could actually use other mutix and other read write locks instead of the one in the standard library. There is like the one is from the parking LOT or the parking lot, which is like way efficient. And also like there is more nicer API for it. It's exactly a drop in replacement for it, but it is like more efficient. I hear like I don't actually know if it's gonna be inside the standard library or it is already there, but yeah, that's what I usually use when I need looking.
Okay, I looked into the parking lot, like into the different read write logs and the different benchmarks, and there were certain cases where it was slower, and then and just know that these options exist, and basically from the user API, nothing will have to change if I switch that out later. So for RID, just to give some feedback there, it's like I'm currently in the stage of make it work. Like you can get like make it work, to show that how you could build app with that, and basically to also build out more and more API and to be able to use more and more data types, for instance, from the Dart side. So, but yeah, definitely like performance tweaks can still happen later on as well.
Yeah, I can also tell you what I'm doing for the protocol buffer thing. Is that I have like a one shared memory buffer between Rust and Dart.
It sounds like there's a really good amount of like cohesion you guys could definitely have, right? It seems like you have quite a bit of deep knowledge in this area that you can definitely offer some interesting solutions. I also appreciate, him kind of just reaching in and just trying to get it all done, because it is quite a bit of work, right? I think you probably spent quite a bit of time yourself digging into how things work and all that.
It's quite challenging actually to to actually make sure of the safety of the data or the state. And for my specific application, this time I tried to use protocol buffer instead of just writing a lot of FFI functions, and with everyone is different parameters and different return type, and everything of course is asynchronous because the underlying client is just using HTTP and or WebSocket to send messages over the server and the client. So what I did is that there is only 2 or 3 methods actually in the FFI side. One is to initiate the client and initialize it in the global state in Rust side, but it is actually there is no looking for it. And the other function is called dispatch that actually takes a immutable view from the Dart side, so it can actually uh, read the data from it, the request it needs, and also the other method, the last method was called the shutdown the client and clear everything. And for the Dart side to send the message, I have like this scheme called there is a protocol buffer thing called one off body. So the one off body is like generates in Rust and Dart and enum with each message, like it contains the data, the payload it needs, and also the variant itself, similar in the Rust enums. And lastly, you send this request over the send just a pointer and the length of the vector you already allocated in Dart, and from Rust you read these bytes, serialize it to protocol buffer, and match over the request, and dispatch the call and send response back over the allo isolate, and that's it actually. And it's quite easy to add more functions as you add new feature to your application. Just you write the scheme inside the protocol buffer definition file and hit generate code that will generate for both Rust and Dart the methods you need. And then from Rust you implement the handler for this request or the new variant you added, and in Dart side you just add a nicer API so you can send the request. I probably should share my screen and show you guys how actually it works in the code. So
yeah, go ahead, Shay. I have a short comment while that's going on. Like, I totally agree that what your approach is like a really valid approach, and I actually have worked with protocol buffers also in Dart before. Definitely interesting. So I feel like we had it's interesting because we have 2 different approaches to the same problem, and I'm kind of interested to see where we both go with it. It seems like your footprint, like you said, like you only have like 2 FFI methods that you actually have to expose because everything else is done via protocol buffers. For me, I don't want the users to have to even worry about doing protocol buffers, and also I'm still a little bit concerned that. Especially if this is going to run like on phones and so on, that the serialization and deserialization, especially if you have large data, will kind of eat into the performance, right? So, and obviously, if I was to use protocol buffers, right, and even like do something like RID, but use protocol buffers, it would be a lot easier, right? Because I wouldn't have to, like right now I'm working on implementing a hash map and exposing the methods on it and iterating over keys and all these things and making that performant. It would be a lot easier to do it the other way, but I kind of I'm going to follow the path and see how far I can get with this, because this is like this approach is definitely the way to kind of get the most performance out, right? And since we're already using Rust, that's kind of like the promise there that you only build your UI with Flutter, but you get everything that's kind of but I mean, assuming you wouldn't send enough data, like it's that much data across, it wouldn't matter as much. But if you don't want the performance to suffer, right? And that's kind of, I'm taking that approach.
By the way, there is other for wire formats. There is like flap buffer, for example, that doesn't really require you to serialize everything to read this specific data, which is really great. It's called zero serialization or zero serialization, something like that. I didn't actually use it before, but I hear it's really great for like low latency networks or games that doesn't really need to serialize everything to just get the data itself. And it's really interesting to look into. But yeah, the sole reason actually for me to using the protocol buffer approach for this specific application is that I don't actually wanted to write a lot of functions. Like I could show you how many functions that I will write myself with every single thing, and maybe adding new feature will be like just copy and paste the old function, just to change the parameters, or maybe I will write some macros for it. But yeah, just a bit ugly for me to just write a lot of FI functions myself. That's why I need only one function, just it's called dispatch, for example. Send the code as a protocol buffer request, serialize it in Rust, do the request or the command, send the response back over the allo isolate itself.
Right, that makes sense. I mean, like with RID, it's obviously a lot easier. You don't have to write the boilerplate, right? You just put a RID export attribute on your function and you're done, right? Now it's exported. And then it generates C boilerplate on the Rust side and then on the Dart side. And then you can access that function.
Yes,
and the same with fields, right?
Yes, that's what I said. I need somehow like what's called a co-generator to help me here. And
right.
I was like a bit lazy to actually write my own proc macro for it.
Right. No, it's actually quite involved as I find out the more I get into RID, to cover all the cases, right? To return a reference versus like if the function returns a vec with the reference of a U8 or versus a vec with U8s in it. So like you have to cover all these cases, but that's kind of the goal with RID, that you just annotate it like that and everything just goes out of the box, right? And you don't have to use protocol buffers or anything.
Yeah, so if you can actually see my screen now, I will just show a bit of how actually it works. So you have like this message, big message called request with like one of body, and every variant of this body is just another message. For example, like get space by ID, just a message here if we search it here, and you will pass like a space ID as you int 64. And for the response for this message, there is like another struct or another protocol buffer message called response. Okay, and the response actually is also one of, and there is like a space by ID also like as a response to the above request, and you just implement this in protocol buffer and hit it, and it will generate something like this in Rust. Let me show it. Yes. This one. So yeah, it will just generate this enum for you, request body, and the space by ID, and also like you get a space by ID the data itself, which will be just a normal struct with the space ID as U64, as we actually added in the protocol buffer. And in Rust, you will have like this function called, as I said, dispatch, that will have like a view or a array view from the FFI side from Dart, and I just create the isolate. I just decode the message itself, the view. If it's okay, I get the request back, and then here the only unsafe code is this. Actually reading the global state, the client. I have a client here, a static client, one cell, and by default it's like none. And then when you call init client, it will actually store the client here, which is like a normal HTTP client to send requests. And just to I spawn another task in the handler that takes the client and the request and then respond back the result. And in the handler you can see here I just match over the request body. If it's like get space by ID, I just call this function and the response back to the isolate. And from Dart, actually, it is more easier to send requests. Like, let me show the subsocial SDK. Here's the dispatch message. Actually, I just create a new completer for receiving the bytes, and that's also I create a single port with it. Get the port, get the request as a buffer, and create a view pointer, array view for it. Send it to the function as we say, and assert the result is okay. If it's everything okay, I just deserialize the response back from the buffer I received. If like there is an error, I just throw an error. Otherwise, I just return the response. And here is how actually I managed to, for example, this nice API future space get space by ID. I send the request as like a normal Dart. This is actually generated by the same scheme file we had earlier. And just call the dispatch function, ensure everything is okay, and return the space. Or it's actually similar to a group or something. But yeah, any questions about this?
It's really interesting, Shay. Like, is this code? If this code is available anywhere, please add a link to the show notes. Unfortunately, I can't really, since I'm on the iPad here, I couldn't see the code that you showed. But from listening to it, it seems like the architecture that you have is actually very similar with the dispatch and everything to how I have Red set up, basically where you send a message to what you want to do, and you may include a little bit of data with it, or maybe like a pointer or something, and then when it does all the things on Rust, and then it posts back a message, and then basically the UI side queries the updated state and re-renders UI. So it seems to be somewhat similar, except the way, right?
Mm-hmm. And even I have like an example application here that actually uses this SDK and also test cases, but it's really simple one. Like the SDK itself, you need the SDK, call any functions you need. Basically, the SDK itself doesn't really hold any state. It just only the client, the connection, and just keeping sending requests and response back and forth between the network and Rust, and send the response back to Dart. Because the whole idea is that we already have the SDK written in Rust, so we actually tries to manage to reuse the same code that actually used in Rust. So we manage it to the Flutter, maybe in the future in writing into WebAssembly, maybe for the browser. But there is already a Java SDK for them, so just Dart for now. Dart, Rust, and Java SDK.
That's really cool. I feel like the main difference that these two approaches just really have is like how to transfer data, right? And you're using serialization, and Red just basically doesn't. It just basically works directly with memory via FFI, right? One question I had, since you kind of said all these things, like what about error handling? Though that's really something that I have started to look into, but when it comes to FFI and kind of handling errors that occur and propagating them back to the client, that's something I still am really like a little bit confused. There are a lot of libraries out there, but they all do it in a very different way. So I would like to hear your experience with that.
So for error handling over asynchronous Rust or Dart, it is like simple. You send the message as like if you have like your message as a struct or something, you send the error over the response. Basically, what happened if you send a result over allo isolate, it just requires the error part to be convertible to string. So if you send there is an error, it will just respond back to in your Dart side with the error string that you have. But anyway, for general idea about error handling in FFI, the idea is basically you send a status code back from the function, the way old C was going with error codes. So if the function is returned 0, maybe it's like if you basically you came up with your preference, but sometimes if it's returned 0, everything is okay. Otherwise, if it's like maybe minor -1 is just like there is an error here. Maybe 1 is like another error. So yeah, just return a number or a status code, and maybe you have enough in both language. The real problem is that to keep both of them in sync, and also to implement the display to make like easier for the user to understand what actually this number means, instead of just throwing the numbers. So yeah, this is actually the easiest way to handle it. There is another way which is called last error, last error message or something similar to the operating systems. So when you dispatch a call or do a system call and it fails, you probably see like okay, I'm gonna dispatch another call to the operating system to say give me the last error message, and it will return a pointer to string, for example. So the way actually it works for you, maybe you could use both of them, like return the error message, or store like a global pointer for the error message itself, or just use a simple opcodes or a status codes. That's what I usually use, by the way, the opcode stuff or the status code.
Okay. Now that makes sense. I mean, in my case, it would be either I would post the reply that I post would include an optional error, or I could just have a general post like that I post for any error, depending on how the application wants to use it. Right? If you want to associate it to a request, obviously it needs to be it can't be a global one. Because the thing is that once you're like multi-threaded, right, the last error thing doesn't really work that well, right? So,
yes. In my case, in this case that I'm using protocol buffer here, if you see the response body, it has a variant called error. So every time I do that dispatch, I just check if the response dot has error. This is like an accessory message from generated code from Dart, and it says basically if this message has an error variant in it. And if it has, I just throw it error because I make sure the error has a structured form, because basically you can have like a kind, also a message, maybe a description, maybe a root cause, for example. Anything you can actually have in this case for the serialization, because you can have structured messages.
Okay, that's really cool. Now, why I also want to talk about it because I looked at different libraries, like I think Safer FFI, and then there was FFI helpers, and there was like a lot of code in there regarding error handling.
I used FFI helpers before. I believe I used it before, and it was working for me. I'm not sure how I'm using it over like multi-threading. Never used it over multi-threading, but the last thing is that in my simple FFI libraries in Rust, maybe some encryption libraries that I'm trying to use to improve the speed of encryption or decryption, some crypto library, for example. So I'm just using status code, and in Dart I will just match over the status code and return an exception class for every single variant, and which is like really working good for this use case. But yeah, just it needs a lot of mindset to actually. There is nothing actually correct or wrong here, but the standard is that using status code or maybe the last error, both of them, anything could work.
What about panics? Like I read that I think right recently now there is a way in Rust to handle panics, right? Have you done that? Because I mean, obviously, like if you have a mobile app, you don't want it ever to crash.
Exactly.
Right? So is there a way?
There is a way in allo isolate to catch a panic that happens inside the task. It will actually report the panic back to the Dart side. This is actually if instead of just calling isolate.spam or isolate.task, just call isolate.catch unwind. This will catch any panic happen inside this task and report it back and recover from the panic basically, which is good sometimes good, sometimes bad, because sometimes like basically panic means there is really something bad happens. So basically you just panic and you should stop the application from getting into maybe undefined behavior or something. So yeah.
Okay, interesting. I think I'm maybe using the IO isolate a little different than you. I read some implementations that basically they spawned up one isolate, and then they would get a reply back, and then for every time they wanted to communicate, they spawned up a new one. And to me, that seemed like excessive. So what I'm basically doing is I'm spawning up one isolate for the whole application, and then I'm posting replies back through the channel, like right.
Well, basically, the way I'm using it right now, the spawn completer thing, actually, it just let me try to find the utilities. Yes, all it does is that it creates a new zone from Dart side. Basically, a zone is just a way to like it's basically a zone, so you can run code inside this zone and get like and it is not actually a new isolate, but it is like to isolate this function or the call from the main isolate itself. So yeah, the way this zone actually, I'm just every time I need to call a new function in Rust, maybe this function will throw an error or something. All I do is just create a new zone, create a new receiver port. Actually, it is not an isolate, a new isolate, just a receiver port for it, which is like it's called in Dart raw receiver port. So yeah, receiver port, and then associate the callback for this receiver port with the zone callback itself, and then just run the code inside Rust, because I know the code. Because I know the code inside Rust will be handled in different asynchronously, and possibly the code itself will run in another thread, not other than the main thread, and the response will be sent over to Dart over this over this receive port. So I know it's not gonna block because everything's just multi-threaded. But if if my code in Rust is just single-threaded, it will block the main thread. That's when actually I need to actually spawn a new isolate that will run or dispatch the call to Rust itself, and then respond back to me.
No, I'm doing something very similar, except that I have one zone that I basically every time I want to post a message, right, to my Rust, it uses that same zone, and it uses that one receiver channel to communicate. But I think that's the main difference. That because I found it like it would be too expensive if we have a lot of calls back and forth to spawn a new zone, and I think you have to spawn a new isolate as far as I know, because you get a new receiver channel. Right?
No, you could just create a new receiver port, raw receiver port.
Okay.
Without
creating
isolate itself.
But you have to at least create that, and then somehow, basically, Rust has to know what that receiver channel is, and you have to connect it and everything.
Yeah.
Okay.
Yep, that's how actually it works. It's just there is like two functions that I usually use. One is called single callback port for sending just a synchronous call to Rust, and there is another one, single complete port, which is just similar to the previous one, but takes a completer instead of a callback function. And when everything just completes, it will call completer to complete with the response from the Rust side.
Okay, cool. No, really interesting. And you said that you did try WASM, or you're thinking of doing WASM. Did you have any experience? Because I actually recently did something with WASM, and I would like to hear first what you think.
You mean WASM in Dart? Inside Flutter application on mobile or on web?
So basically, like to be able, like I basically what I did, I managed to implement the to-do app to run in the browser, and it's using RID, and basically it communicates to Rust, but at that point Rust has been compiled to WASM, right? But a lot of things are a lot more trickier, or it's impossible, like when you start using WASM. So I would like to hear, did you like implement an app that maybe did run in the browser? Yes. Okay.
Yes, I actually in my company we're building privacy bridges of our cryptocurrencies and the blockchain. So we have like a lot of cryptography libraries, and we wanted to use the same crypto libraries inside from Rust, because everything is just written in Rust and Solidity for EVM stuff. But yeah, we wanted to use the same crypto libraries inside JavaScript, and because we have like a web UI or a web application. So what we did is just reuse the same code without any changes, because our code already was no STD compatible, because even though we are using Rust and running natively, our code actually is sandboxed, compiled to WebAssembly and running in WASM, I guess.
Right, but to
environment.
clarify, you're not using Dart, right? You're just using directly JavaScript
Yeah,
to WASM, right? Okay.
JavaScript
Yeah.
WASM, but yes,
Right.
that
Okay.
was easy because we have a lot of like, at first it was using serialization for a bit, then we just managed to using WASM binding, which make everything is easier for us. Yes.
Do something slightly different. I tried to get a Flutter app to run in the browser, which you can do, and then use WASM with that. But that proved to be quite difficult. So like you can't. There wasn't a library like FFIGen for WASM. So I kind of, it's like a JavaScript like JavaScript, right? It worked pretty much. Like a lot of things worked, but there were some things that were really kind of blockers. One thing was that, and maybe you solved that in your implementation, like multi-threading, right? You cannot just go and create a thread in Rust.
Yes. There is no multi-threading in WASM as long as I know just web workers. And
right. But I mean, you have to somehow build that whole. I mean, I'm not aware of anything that yet does it for you. There's actually a really good blog that I found that talks about how that could be done, and after and it involved web workers, obviously. But after reading that, I realized that there's
so I'm aware of asynchronous Rust over browsers. They actually because Rust is designed, the future trait is designed that's ball based. So what they did actually, they had when you create a future in Rust, it actually creates a promise on not actually a promise. I don't actually remember, but they are using a function in JavaScript, I guess Windows Next Frame or something, to drive the runtime for Rust. Basically similar to Tokyo and async for asynchronous to pull actually the future and making the futures to progress. They actually managed to have a way to write the runtime in JavaScript to pull the futures in Rust, and this is how actually you can use futures or asynchronous Rust inside WASM. But
super interesting.
Yeah, I'm not sure if it's like it is already there is people using it, maybe. And there is I guess there is a guy working at Google Chrome. He managed to use Ryan library. If you don't know Ryan library, maybe Alan know it too. It's just a way you can you use the same code for your iterators and make it run parallel by just changing, instead of iter, you change it to bar iter. And he managed to actually make a binding between Ryan and WASM binding and WebAssembly by just spawning a worker bool and then run it like using threads in the browser.
Okay, but basically, like, there's still a lot of plumbing still involved. Like, it's not just straightforward. Yeah, that's what I found, and that's why I up-ordered that part for now, because I didn't want to crawl into that rabbit hole too deep. Another thing, obviously, for WASM was to be able to allocate, right? So you need to implement an allocator function on the Rust side in order to even send a string, right? There was another issue, and then one issue that I ran into. Go ahead.
Well, basically, in WASM there is like just one buffer, and you write to it, or maybe bump the buffer to maybe grow it more, but just a single buffer, and it's just shared between the host and the WASM environment. Yep.
No, actually, what I did is I implemented a allocator. So what I did is, like, you want to send a string as an argument to my Rust function, right? So I can figure out the byte length of that string, and then I basically go to Rust and say, hey, allocate me memory, and then it gives me back the address, and then I can write that string there, right? And then I send that pointer to the function, right? And then after I'm done, I call free, which is also implemented in Rust. So that's the way that I'm doing. But one way that I could not figure out, and someone on Twitter actually gave me some points that may be possible, but to send a struct back from Rust via WASM, like it just basically would crash with like non-descriptive errors, like and that was really, really difficult. Like sending strings worked, sending primitives worked, but sending like a struct did not work at all.
Well, there is a way you can. I guess there is a way you can do it. And instead of actually sending a struct, you can send an op pointer. That way, JavaScript side doesn't really have anything to do with it. It just holds this pointer, and whenever the JavaScript side tries to, the Dart side or whatever you are using, it's similar to JavaScript host, by the way. But whatever you want to dispatch a function or a method in this struct, or maybe access the data itself, you send this over to Rust, and Rust actually casts this raw pointer to the struct, which is unsafe, of course, and you get back your struct, and then just dispatch the call or dispatch the method itself in this struct, and send the response back, similar to a function call normally, an FFI call. But yeah, just op pointer.
It's getting pretty interesting. I'm actually hearing and learning a lot. Because I know that I was thinking also about trying to help out with the WASM stuff. Of course, I've been crazy busy, but that is something I'm really interested about, because thanks to the work you did, like I managed to get something working basically for all platforms except WASM. And yeah, that would have been amazing to have, because like I delivered like a Windows app, a Mac app, and then I think the last thing is if I could deliver a web app.
For the web, in my idea personally for a web, I will just write or use WASM bindgen, and from WASM bindgen, it will actually generate for me JavaScript glue for my Rust code. And then from there, I will just use the JavaScript from Dart, which I guess is very, very easy and possible. So that's what I am thinking about. So you write your core functionality in just pure Rust. It doesn't really depend on FFI, allo isolate, or anything. And then you write an FFI that will be used for every other platform except of course WASM, and you have like a WASM library or a WASM variant over the core library you have for us, and just use WASM bindgen that will generate a JavaScript file and the WASM file, of course. And then from there you can call the JavaScript functions from Dart, similar to actually anything, or the browser API or something. And that way actually you will have like universal application. That's what I am thinking about. Not sure if it's gonna work in the future or something.
That's interesting. I mean, like the thing is, what I wanted is like to not have for the user to not have to call into. I mean, that's basically what WASM interrupt does, but I didn't want the user to have to write this by hand, right? The interaction with JavaScript. So yeah, it's definitely possible, but I think it's a little bit more on the horizon. Like I now reread the tip that someone gave me. It may have to do like not being able to send structs is with linear memory. It may have to do with like some layout issue in WASM or something that you have to basically set up. And I think you said like to just send opaque structs, right? Is that basically what you said?
Yeah, opaque pointers or opaque structs.
Yes, that's what I'm doing mostly. But if I have like a vector, like I have to, it's like a fetch pointer, right? So I cannot just only send you a pointer. You also have to have the information about like the capacity and the length, right? In order to instantiate it on the Rust side. So that's the only case where I'm actually sending a full struct. And but even like for opaque structs, if I remember correctly, I had problems getting this to work for WASM. So I'm not sure what went wrong there. Yeah.
Well, I have also another issues with FFI in general in Dart. For example, when I call FFI dot malloc or malloc, similar to the one in C, and I allocate a struct in FFI struct in Dart itself, and then I get the reference to it, mutate the data, and send this back to Rust. So basically, what I think is that after Rust done with it and get back the response from Rust, I am the one who responsible to free it. But when I call the free call from the FFI on the pointer that I had from the malloc function, it just crashes my Dart application and says I'm doubly freeing the same thing, which I'm sure I didn't actually free it in Rust, but I'm not sure why it just freed itself, which is like really strange.
Well, if you just return it, right, it basically Rust will end up dropping it, I think. So no, you have to basically, when you
Rust only took the pointer and length to the function, and even though if it's like already dropped, it's just a pointer, a raw pointer, so nothing really. But yeah, maybe.
Right, but I think so. Basically, like what you have to do, like let's just say you're getting a pointer to a struct, right? And then you want to operate on it. So I send you the pointer from Dart. Then on the Rust side, I instantiate it. Well, at that point now, I have a reference to it, and if I don't do anything special, it will just get dropped, right? Because like if I send a reference, for instance, on like if I don't send the whole thing back, right? If I send like something that's on it, like I say an ID or something, like I return that. Well, now I instantiate, let's say, the store, and if I don't take care of it, like the store will now get dropped because it's no longer used, right? So what you have to do is you have to say manually drop, and have to tell Rust that I'm going to take care of this, because I think when it gets dropped, also the pointer becomes invalid.
Yeah, that's already clear for me, but maybe I'm not. I need to describe more. So let's imagine I have what's called an immutable array view. So the struct is defined in Rust, and it has a pointer to the first element of the data and also the length. So I can from Rust side I just create a slice, or by giving what's called the function from a slice and length or something, from a slice or slice, something like that. You just give it a pointer of the data and just the length, and it will give you the slice back. So this actually works everything in Rust, but when I generate the code in Dart side and I allocate the struct in memory in the heap from the Dart side without calling anything to Rust, just using ffi.malloc, the function from ffi Dart, and I get back the allocated pointer to the struct that I have. I then write to the first element of the pointer of the first element of the bytes and set the length. So now I have the pointer. I can send it back to Rust that can Rust operate on it, the struct itself. But Rust doesn't really have to drop it, even though if it's dropped the element, it's just a pointer or maybe a borrowed view. And when I get back, try to free the pointer and the data itself, just saying I'm just double freeing things.
That's interesting.
Yeah, that's quite strange for me, because I didn't actually free it in Rust, nor I have no idea why it does this.
But you're basically constructing the struct in Dart, is it right? Like you're allocating. Yeah. Okay, so I don't have a case that where I'm doing that, but what I could imagine is that maybe you're writing, when you send it to Rust and then you let go of it, like Dart doesn't know that memory is still being used, and it might garbage collect, right?
No, so it might actually be garbage collect the managed memory. When you get a pointer, just have like the heap itself, it just maybe it has separate memory regions for the GC to operate on, and the exact thing. But I need to look deeper, maybe open an issue for FFI to clarification for this stuff.
That's really interesting.
It's really strange for me. Yep.
But just referring to when you said the slice, you're doing from raw, I guess. They also include the capacity, right? because otherwise you're
But
going to be leaking memory.
This is only for vectors that I allocate from Rust. I need also the capacity. But for my side, for my use case, the actual memory and the actual bytes is allocated in Dart. This is actually when I send the request to Rust basically. And
Interesting.
convert the protocol buffer to the raw memory, uint 8 list, and then I get convert this list to the raw pointer or as typed buffer, and then send this buffer, get the pointer to the data, get the length, send this back to Rust, because actually Rust doesn't understand the layout of the memory buffer from Dart. So I have to have like in basic struct to have this data, the length and the first pointer of the memory, and send it back to Rust. From there, Rust can actually convert it to the slice, just a immutable slice. Doesn't really have to mutate anything actually, and Rust doesn't really responsible for freeing anything because it's just a borrow the slice and serialize it back. I have my own serialized struct now, so Dart can freely free the memory. When I try to free the memory, it says it's already freed. So
okay.
no idea.
That's interesting. I didn't have a use case for this because the idea that I had with RID, and maybe you have a different scenario, but the idea is that all the logic that you write is in Rust. And the only thing that you really do is you relay user actions or anything that happened to the Rust side, which then does its thing. And then when you render, you just get the state from Rust, right? So like for me, there was never really a reason to send a whole struct, but maybe I'll run into that as well at some point.
Yeah. I hope like I had like a clarification for it. Maybe I will message you when I have, or maybe you could see the issue itself. I will post it soon.
Yeah, it's added to the show notes too.
Okay, sounds like there's a lot of stuff going on. Yeah, so I've been listening. I can't catch up with everything said, but I do understand quite a bit of it. Yeah. So it's interesting. I do remember about the FFI stuff, and I did follow up with errors that one I used from Shady, right? Now, I think an interesting question is like, how do you guys actually want to manage state between the two, right? So I think both of you guys are basically saying keep your state within the Rust side, or are you actually saying, yeah,
right? I mean, the idea is that ideally, like I just said, you wouldn't have to send a struct, for instance, from Dart, like unless there might be some case, but I mean, you could send like a string, right? Like say the user selected the login. In the ideal case, you only send strings and primitives to the Rust side, and the Rust side then updates the state and then allows the Dart side when it renders to access that state. That's the ideal case, and it seems like Shady needed some other functionality, and maybe, as I said, I may run into that as well, where maybe you have to send more structure at all in Dart. That at least that's the philosophy of RID. I even have an example that uses block and qubit, but the qubit version of block, however you want to call it. But basically, in that qubit, there's no logic at all. All it does, it relays messages to Rust, and then it listens on the reply channel for certain events. Like say, I that added the to-do needs to know about it. Also, other parts of the UI need to know about it. So coming in, so if a to-do was added, I need to update my to-do list, obviously, right? So the list qubit then listens for those events. But again, all the logic is on Rust, and all the state is on Rust as well.
That's really interesting.
But here's the problem: is if you put all the state into Rust, right? Because Rust is a compiled language, like you really lose that balance. So, like, say if you just made a simple mistake and you want to change it, right? Then you have to wait for it to compile again, and then you have to actually restart the app, right? If I understand correctly, because this is Rust and it's a compiled language, as opposed to, sure, Dart's compiled, but also has a hot reload feature, which Rust doesn't have out the box. But I know there's people who are implementing this kind of thing, but they still have another language on top of that, unless I'm misunderstanding something. if you do go your route, right, once you change into Rust land, you're going to miss out on like fixing small bugs in your Rust code and having that nice ability to have an auto reload, and you will be good.
Basically, the idea with RID, for instance, is that you implement your logic, and for that you might be doing that test driven, right? And now when you are and so on, and you get that right, so that's one approach where you still get the hot reload benefits. Also, Rust doesn't compile that slowly. If you just run tests all the time, it's actually really fast feedback loop. For the WASM file over the network, which I'm basically doing in that example, is that you can basically recompile your Rust to WASM, and without restarting the Flutter app, you should be able to basically update that WASM file, right? So that then basically you don't have to basically shut down the app and restart it entirely. You can probably just do a hot reload, might not work, but a hot restart at least would work. So that's really fast still. So then you still get your updated code. So once the WASM story is better, we could actually use that in order to doing development, at least. If you're developing like a Mac app, you could still use WASM, right? And develop iterate faster that way.
Well, I had this idea about using WASM as writing your logic for development, but it was like the sole idea is that I have the host functions running in Rust, and the logic for this function is written in other language like assembly script, for example.
Sorry, which part was written in assembly script?
The logic itself, like maybe you have like your application is depending, for example, a function that get a square root of a number, okay, and to actually get this feedback, you maybe want to like implement a square root, so you implement it in an assembly script, and this assembly script is compiled so fast to WebAssembly, so small assembly file, and you have like in your core application while development, of course, you have a watcher that watches for it for if the compiled file is changed, and then hot reload the instance of this module, the assembly, the WASM module, and this it automatically calls the function again, without losing, of course, the state, because the state is maybe the number that you trying to like square root it is already in Rust as a state, but the logic itself is written in assembly script. It just was a proof of concept of using WASM inside game engine, so you can have this hot reload itself. For you, there is a guy in Twitter called Faster Than Name. He wrote a he actually has a very good blog, and in one of his blog posts he was actually building a hot reload for Rust to build a GUI library just for fun and actually experiment with hot reload itself. What he actually did is that the core library for Rust is just written in the core library for the UI is just written in Rust, and it's formed like the shell or the window, and the core logic for styling and stuff like that is written in FFI loadable library. And what he actually doing is that once he changed anything in the core library or the logic and hit save, there is like a cargo watch command that will compile the code, and in his shell window code the core library that actually using the shell window will reload the library, and uh, just apply the change to the UI itself, which is really cool because it was really fast, and it was just a proof of concept, of course.
From my standpoint, like from my experience doing apps like this, is that we're tweaking the logic all the time, right? Like writing the log when you're actually working on the UI. But it's really nice to hear that it was an idea, and or even combined with WASM, there are more options on the horizon that we could use. That's awesome.
If I remember hearing correctly, it's possible to use WASM while on Mac. You're saying like if you're developing on your Mac, somehow WASM could be used to reload the code for the Rust logic?
Yes, 100%. Actually, like it would be easier, right? because if you're on a Mac, you could actually use WASM. What is it called? WASMer, which is basically a library that gets compiled to basically uses FFI bindings themselves, right, to interface with Dart. That's why it doesn't work on the web. But basically, yes, you can compile your Rust code to WASM, and you can run that WASM in Dart directly. And then you could basically update that all the time and refresh it. And hot, at least like restart the app, like hot restart, right? That would still work. About hot reload, I don't know. But basically, you could get the WASM library over the network and instantiate it and set it all up, and now you have the updated version, right? That could even allow you to potentially get an app into the App Store and then update its logic after the fact. You could do like bug fixes after the fact. I don't know if Google would like that, because obviously you could also do bad things that way. But yeah.
Well, for Google there is already applications that running WASM, but I guess Apple won't like running jittered code. That's why actually I don't think Dart WASM will be shipped anytime soon in iOS applications. I remember back then, Dart actually, when it was compiled to compile an iOS application, wasn't actually allowed to be in an Apple Store, because Apple doesn't really want what's called agitated language. It needs like an AOT language. That's what I remember. It's the very beginning of Dart.
I think I remember. Well, I don't know about this being an issue, but I know that now they allow that, and I think I remotely remember this issue because they didn't want people to push, new features, right? That I think I remember something like that. What I remember is that they didn't want people to like skip the review process, so like you wouldn't just be able to push new features without getting them to clear it. And that could also be dangerous too, right? Because even nowadays, right, people could just push some kind of minor onto your device.
Well, I heard that there's certain application, I won't say its name, but there's application that has a permission to download any zip file, extract it, has an executable in it, and run it inside the environment itself, like Android or iOS. But yeah, it's a very, very popular application, a social network actually.
That's pretty interesting. So you're saying that actually when when Flutter first came out, it was actually more of a JIT language rather than AOT?
Not Flutter, I guess Dart. And yes, I heard this talk from a guy from Google. He actually was like 4 years ago, and 2018. He was talking about multi-threading in Dart and the isolate back then, when actually there is no way to run other isolates besides the main isolate in Dart. And it was like way back in the very beginning of Flutter and Dart. So it was a blocker for them to get applications to be published to an app store. It was fun and running in what's called in iOS simulator or something.
It's pretty interesting to hear. I didn't know about this.
Yeah, but basically to connect to the whole WASM thing, and like the possibilities are a lot. But basically from what I ran into when trying to use this from Dart, they're like, and I wrote a blog post about it, which we should include in the show notes. I ran into a lot of basically missing pieces still, which are definitely going to be possible. It's just a lot of work that still needs to be done, which I didn't have the bandwidth to do myself. But I think once kind of the kind of Dart integration with WASM, especially also when it comes to using Dart and WASM in the web and in the browser, when that becomes better, we have like a lot of possibilities. And then also the idea of using WASM for development, even when on a Mac, and using a Mac app to run your Flutter, that should also become much more easy to do, right?
So yeah, I had this conversation on Twitter with I'm not sure his name, but his Vishlev Egorov. He is like working on the Dart compiler and the AOT itself. And this conversation is a tweet on Twitter when Sasha, one of my friends on Twitter, retweeted the Dart lang WASM repository, and he said like, I can't wait to try this out. And I said yes, I would try this out, because this way I could just, instead of writing if I will just compile my code from Rust to WASM and just run it in Dart, and of course it would run in the web. And he said the compiler, the guy who is working on the compiler itself, he said, why would you use it in mobile where you can ship the native implementation? Is it like to waste the battery for nothing? And when we talked about this, he actually said the abstract intermediate level between your code and the underlying hardware, about like the WASM itself. And he showed like a benchmarking between, because he asked what's my use case. I was like crunching numbers. I am actually writing something that would do cryptographic and some stuff like that. He then shared a benchmarking between WebAssembly and the native, and on the popular browsers, and also the popular outside of the browser runtimes like Wasmer and Wasm time, and there is also WAVM, and everything shows that the WebAssembly implementation or the WebAssembly runtime runs everything like a bit slower, like sometimes way slower, by in percent like 80% or maybe like less than that of the native speed. So yeah, he got also a point, is that if I don't have actually to run it inside WASM, why should I? Yeah.
So like definitely the native implementation, I mean, if they do it right, should always be faster, right? But in this case, like you would only use WASM to be able to at least run it in the browser, even if it runs slower, right, than native. And then the other option that I was referring to was like only in development mode, right? While you're working on your code, you could use, and even if you're running, if you're showing it in a Mac app or something, right? You could then iterate a little faster on the Rust code, because you could just refresh or a hot restart, right, and see the changes. Yeah, but definitely when you ship, I totally agree that you should then just ship it as compiled Rust, yeah, native.
I think we had a really great conversation today. I mean, we started a little bit late, but I think once we got things going, like I think it felt like forever, but not like a bad forever, because I was definitely eating everything up you guys were talking about. But there's just a lot of cohesion between you two guys. I think you guys should really try to, work together, at least on Rid or maybe some other things, because it seems like there's a lot of really good ideas between the two of you. And I think it could be quite interesting what could happen between the two of you guys.
Interesting. Yes, sure.
Yeah, I totally agree. I just hope it wasn't too much Rust and lower level stuff, since this is a Flutter podcast. But
no, I don't think so. I think actually, I think the most popular episodes we have is about Rust, because people have a huge amount of interest in Rust, and I think that Rust and Flutter are definitely, for sure, Rust is one of the most loved languages, right? And I think Flutter is definitely one of the most, probably maybe the most loved, like, I don't know, what do you call it, multi-platform or cross-platform kind of GUI, making app kind of solutions. I don't even know how you say it. Like, I can't imagine there being a more fun one to use, right? Even people like using iOS, Swift UI, I hear a lot of complaints about. I haven't heard very many complaints about Flutter, very few, and that I think is really the power of it.
The most hot topic in Flutter is the state management. Yep.
No, I agree, and I saw the same like UI that runs everywhere, but that's currently not available for Rust directly. But I also want to use Rust to program my app logic. And yeah, and then also since you said state management, Shady, like it kind of removes that entirely, because all you're really doing is you're delegating to Rust to really manage the state, right? I mean, I still use Qubit, as I said.
That's also my best choice for state management for my applications personally, and also when someone asks me recommendation, because it just for me personally, it does make sense to how actually it's architected. Sometimes it's overkill, but in the long run, it just pays off when you start with something like Block or Qubit.
Is there anything else you guys wanted to mention or talk about? I think for sure Thorsten probably has something he wants to throw out. Please go ahead and say it.
Yeah, just I hope that we included a thing to be able to write Flutter apps with the logic implemented in Rust. And as mentioned in the previous podcast, I'm still looking for sponsors. Over 30% now to my sponsor goal to fully open source RID, and to make it sustainable for me to keep working on it. And yeah, just give it a try.
That's really great. I hope this project comes to like the light soon and open source. People can contribute and improve it over time. And I also just shout out to the people that are actually working on the Tory UI. It's just a way instead of building. It's a cross-platform for building desktop application instead of Electron. They actually do a lot of stuff between the Rust and JavaScript side. So probably first you should look how they actually do the communication, maybe the state management and stuff like that. Because the core logic you write in Rust and the UI itself is written in JavaScript in your favorite framework for JavaScript, maybe React, Angular, anything. It just ships. It uses the already installed web UI or WebKit. For example, in Windows it will use Chrome or the Edge, whatever. In macOS it will use the Safari one. So yeah, it doesn't really ship the browser or the Chrome in everywhere, but it uses the already installed system default thing. And create a web view, render your UI application, and your logic is already written in Rust, so you can communicate between them. I'm not sure how actually it's under the hood. There is documentation and stuff like that for development, of course, but they actually doing really good job at this.
Yeah, I remember hearing about this. I think I was playing around with it a little bit, and I was thinking about doing a video about it, but yeah, I just haven't gotten back into it because I think at that time the documentation, I just couldn't wrap my mind around every piece of it, but it seemed pretty solid. I was always interested in using Rust in the back end for logic, and yeah, I think this is a good project. So thanks for.
It is in final beta now, so it's gonna be version 1, and the API will be locked down after a lot of iterations. I guess it has been like let me check. It's been like a lot since actually this repository started. It's about like 2 to 3 years ago, and which like there's a lot of development going there. So yeah, this works actually shout out to everyone who is looking for, instead of developing Electron based app with and like ship like a lot of megabytes application for just a small page or small UI. You can use actually the Rust core and also writing your favorite UI framework.
Great. And if there's anything else from you guys, otherwise I think we should probably sign off.
Everything good for me?
Yeah, I want to thank all my sponsors that are currently already sponsoring me, which are basically motivating me a lot to keep going with RID. And yeah, that's pretty much all I wanted to say.
Awesome. Thanks again, guys. I think we should probably do this again. There's another guy who's also working with Rust and Flutter. I forgot exactly what he was doing, but I believe he was wrapping a native container written in Rust around Flutter. I think I shared it with you guys, but I believe I shared it definitely with Thorsten a while back, a few months back. I wanted to get him also on the Rust Roundtable, but he didn't get back to me. So yeah, I think that's also a really interesting project he's working on. So, okay. Yeah. Otherwise, thank you guys for joining. I think we should probably do this again when we're, after some time. Let's see how, if we solve any more issues with Rust and Flutter from Shady, and also see how far RID is actually getting, going along, because it sounds like it's really moving along. I keep seeing PRs all the time, so I can imagine it's really moving forward. All right. Thanks. So, see you guys.